Alright guys, we're on to our last three examples for related rates. And I would challenge you at this point to not look at the videos. Try to go through these three problems and try them on your own first. Work with a partner, see how far you can get, compare your answers, look at your E, G's, and F's and see if you agree on those. But don't watch the videos first. Let these just be a solutions manual for what you're going to need. Because I'm going to go through and instead of talking my way through these, I'm just going to put the solutions up and just point a couple of things out. So give yourself a few minutes to try these, pause the video, and then come back to it and see how you did. Again, don't cheat your way through it and just copy down the answers because that's not going to help. Make sure that you actually go through and do these out and feel comfortable about what you're doing moving forwards. Alright, so come back in a few minutes and see how you did. Alright, in this one, again, a little Pythagorean relationship, x squared plus y squared equals z squared. When being told that t is equal to 2, you're told that information so you can get some lengths on your triangle. So if you know the rate is 62, 62 times 2 is 124 miles for the x direction, 55 times 2 is 110, and then knowing x and y, you can get z to be the square root of 27,476 miles. That gives you your values of x, y, and z. When you generate your related rates equation, I've just canceled the 2's out because if you've done enough of these, you know that the 2's cancel out. Substituting x dx dt, y dy dt, and then z looking for dz dt, we end up getting that dz dt is equal to the square root of 6869 miles per hour. It should be the exact simplified form of the answer, not the decimal equivalent as asked for in the problem. So that one's a little different in that they give you the t equals 2 and see if you know how to use that, and sure enough, it leads to this answer. Alright, in this problem you were given a very similar problem that you saw out of the book. You have a jet, the jet over the radar station, very similar problem here. So go ahead and use that as a model for this one and see if you can get the how fast the distance between the jet and where you are is changing. Estimate your rate to the nearest tenth. Alright, so here we go. We once again have the right triangle relationship that x squared plus y squared equals z squared. We're given that at this given time x equals 6. The plane is flying at a constant height of 2, which allows me to find its diagonal distance as the square root of 40. So knowing that dx dt is equal to negative 625, and again you want to make that negative because it's approaching you, so the distance for x is getting smaller at this time. What is dz dt? And if you envision that as x is shrinking, dz dt is also going to shrink. So dz dt should come back as negative. Y is constant in this. The height of the plane is always 2, which means that there is no dy dt. dy dt would be 0. So in the related rates equation, I only have an x dx dt and a z dz dt. Substituting in my values, I can find dz dt to be negative 592.9 miles per hour. And then again, it should be negative because it is shrinking. This question could ask you to look at just the scalar without direction, but it didn't really say that. It just says, you know, how fast is the distance between you and the jet changing when it's at 6, and I think you want to describe that change as negative or positive to let the author of the problem know that you understand that it is in fact shrinking. So there it is, the second jet problem. And last but not least, the last problem in this packet is the Frosty the Snowman problem. Here you're given some information about your old friend Frosty that you built. Can you find the rate at which the radius is changing as the cubes, as the spheres are starting to melt? And just a little reminder that the volume of a sphere is 4/3 pi r cubed. Alright, so doing this one out, using the 4/3 pi r cubed equation, given dv dt is negative 50 and r is 175, we're looking to find dr dt. So I solved my related rates equation for dr dt, which is dv dt divided by 4 pi r squared. And I get, by substituting in the negative 50 and the 175, negative 1 over 2,450 pi centimeters per hour. So not a lot, but it is decreasing at a very small rate per hour. And that's the end of related rates. So you guys have quite a few problems to try out of the book. Make sure that you try to use the approach of the EGF. Go ahead and draw yourself a picture if that's helpful. Consider what things are constant and what things are changeable. If they're constant, remember that their rates will be zero. Their rates of change will be zero. If they're changing, don't substitute in until after you've taken the derivative, because if you substitute in prior to, you're going to end up taking the derivative of a constant, and it'll make it look like it's not changing. Okay, hopefully this has been helpful. Hopefully you have lots of notes to go off of now, so give them a try.